Welcome, everyone, and thank you for joining us today for our Emerging Technology Webinar in partnership with Cloudera. My name is Ken Monty, and I'm the lead solution architect at Fierce Software. Fierce Software is a small woman-owned value-added reseller. Our strengths are in enterprise open source solutions, primarily in secure platforms, DevOps and data analytics. Most of our customers are in the public sector. We deal directly with system integrators, so your GAs, Lockheeds, Leidos, so on. And we work with them to put a lot of these logos together to do some really cool things. We enable our customers with some of our value adds, such as complimentary training, webinars and workshops. We can deploy virtually, on site, coast to coast. We were in San Diego not too long ago doing a 3-day DevSecOps bit. Westfield's for security workshop right after that. So holler at us if you got our little social bits down there. Today we'll be talking about some of the emerging trends and technologies around data. And there are some powerful changes around big data, data analytics, and data sciences, what have you. These changes can either produce a better, more cohesive experience or drive devastating division. Whether you're a nation state, a flush, large enterprise, or resource-strapped organization, data will either make or break you. Now, before we get into too deep of the esoteric nature of life, love, and data, we'll take a look at how some of this all started. Since IT modernization has been driven hand in hand with data management, we'll see how things have changed over the years, including a recent change from Hortonworks and Cloudera. We'll take you through a peek into what's in store, how it affects you, what your next steps are, and there's even a little demo at the end of this, so long as Murphy doesn't show up. In order to know where we are today and how we got here, we should take a brief look back at how the Hadoop ecosystem was planted and grew. Most people think of Hadoop and this cute little yellow elephant pops into their head. The next thought usually goes to something, something, big databases, something, something. However, Hadoop is more than just a solution to the limitations of traditional relational databases. The Hadoop ecosystem can trace its roots back to the early days of the internet and everything we know and use today. In 1997, Doug Cutting started working on the first version of what would become Apache Lucene, a full text search library. What that means is it's able to power the sub-second queries that you get from Google. Great. With fast search, we can now inspect data. So with the help of Mike Caffarella, Doug created what is now Apache Nutch, a crawler, spider, otherwise data scraping robot. They started to literally crawl the entire internet. And with the Lucene, we're able to search across almost everything crawled. As you may assume, crawling and searching the entire internet is a large order. It was around 2002 where they started to experience stability issues and started to design a system and software that was schemaless, durable and self-healing, and could be deployed on commodity hardware. Now around this time, Google releases their specification for the Google file system, which solved many of the issues they were facing, and so they set to implement it in Java. And thus the Nutch distributed file system was born. Now that these projects could tackle the task of crawling, searching, and storing large quantities of data, there was a challenge of processing this data in a distributed fashion. Most other solutions would transport the data to a large computational engine and then ship the results out. At this sort of scale, that was pretty much unfeasible. So enter MapReduce by Jeffrey Dean and Sanjay Gimawat. MapReduce solved parallelization, distribution, and fault tolerance by mapping parts of jobs to all nodes and then reducing slices of the work back down to the final results. And around this time, The different projects were moved from sub-projects of the Lucene group into a new Hadoop ecosystem, which consisted of, at the time, Hadoop Common, the Hadoop Distributed File System, HDFS, and MapReduce. Hadoop started to pick up steam enough to where Yahoo, everybody remembers them, right? They replaced their legacy C++-based search engine with Hadoop, and within 6 months, were running a 1,000-node cluster in production. And everyone thought, how could a Java program replace a robust C++ system? Surprisingly, it did so with relative ease. So between the community and Hadoop's use in production, Hadoop was granted a top-level project in the Apache Software Foundation. After this, we saw an explosion of other projects submitted to be part of the Hadoop ecosystem, a lot of which you know today. HBase was offering to the Hadoop ecosystem a natural database on top of the scalable Hadoop distributed file system. Zookeeper aided in coordinating distributed systems. Then Yahoo, they consumed Hadoop, but they also helped produce Pig, the programming language that extends MapReduce. And then Facebook, way back then even, contributed Hive, the first incarnation of SQL on top of MapReduce. Now, if that weren't enough, in the same year, Cloudera was founded by Hadoop experts from Berkeley DB, Google, Facebook, and Yahoo. Now, there are too many events to name in the history of the Hadoop ecosystem to chart through all of them at this point. But a few to make mention are that by 2009, a decade ago, Amazon was already offering MapReduce hosting as Elastic MapReduce. And then in June of 2011, Hortonworks was founded by 8 Apache Hadoop committee members from Yahoo. And by 2012, the next year, Hadoop's cluster hit over 42,000 nodes in production. And at this point, there are over 1,200 contributors to Hadoop projects. Now, at this point, you'd think we'd have the world's problem solved. But enterprise-ready data management requires even more as things evolved. So Hadoop helped solve some issues related to cost distribution and scale, and is used around the world. As the deployment of enterprise data was adopted, additional challenges were presented. As organizations started to adopt enterprise data practices, there was soon an issue of having many different data silos from different teams. Often these different silos were disconnected, housed different kinds of data, and were rarely alike format. So what many people had were small snapshots of different points of insight without a way to get the value of correlating that data across their entire data plane. And as data drove more and more value and helped move IT from a cost center to a revenue-generating part of the business, integrations became mandatory. Not simply between different teams or systems in your organizations, but interchanges between businesses helped pave the way for the hyper-aware and hyper-active capabilities that we take for granted now, like being able to know within moments of when your Amazon package has been delivered. And with the additional integrated repositories of data and a scalable platform, analysts and scientists could now create and employ models that were previously technologically impossible. This science can range from predictive measures on equipment to social economic patterns on a global scale, the tracking of public epidemics, exploration into the depths of the genome, and personalization functions that improve engagement. Now, data at this point has undoubtedly accelerated business and the missions of many agencies. However, as the value of commodities like data increase, so does the appeal to malicious parties. Now, throughout the years, and even more so in the recent few, we've seen time and time again about an organization or agency that has been breached. Now imagine the number of systems breached, the amount of data that has been exfiltrated or tampered with that hasn't been detected or reported. Organizations now more than ever have the requirement and often legal responsibility to keep their data campaigns secure. So throughout the years, the Hadoop ecosystem responded to these challenges. Cloudera put years of work into next generation sciences that enabled new forms of machine learning and artificial intelligence. Hortonworks provided the development into advancing and expanding the Hadoop foundations to produce an enterprise-ready data platform. And now, thanks to the merger, the band is back together, as I like to say. Cloudera is now unified with the most robust data science platform that is committed to being open source, which is very exciting. So now with a fresh coat of paint and the best and brightest all under one roof, Cloudera has come out of the gate with incredible speed in order to define their unified solutions and to get them in customers' hands as soon as possible. Cloudera is now poised to power all of your data, be that on-premise, in the cloud, and from the edge to AI. Being able to gather, transform, stream, and store everywhere around any device, in any environment, and between them is critical to efficient data campaigns. This capability is what's empowering people to get clear and actionable insights from complex data anywhere and makes the hybrid cloud data platforms an actual reality. So what Cloudera is bringing to the table is their enterprise data cloud. IT operations can provide the framework, foundation, for your organization's data campaigns in any environment with an extensible platform. Business can rest assured knowing that between these different clouds and different data centers, that the legal obligations imposed upon the data can be represented as data governance policies in combination with multi-layer security mechanisms. And as great as all that is, your analysts and scientists couldn't and shouldn't care less about most of that. So Cloudera is enabling them to jump right into their work using whatever tools they'd like in a streamlined fashion that helps evolve simple experiments into vetted models, into jobs, and into the value that drives your mission. Now for a quick look at how things are shaping up with the merger of these technology platforms. My favorite part, right? How do these things mix together? So the merger was bolstered by the symbiotic ways Hortonworks and Cloudera were already developing the technologies. The latest releases of Hortonworks Cloudera platform and Cloudera's CDH have embraced and modernized on other enterprise open source technologies such as Kubernetes and Red Hat's OpenShift. We're seeing the first round of Cloudera and Hortonworks collaborations bear fruit. You're now able to run Cloudera's Data Science Workbench on HTTP for a quick way to rally around your experiments. And one of the latest developments is the integration of Apache NiFi into Cloudera's Enterprise Data Cloud platform as Cloudera Dataflow, a scalable real-time streaming analytics platform. And there are other things that have been speculated based on the previous work laid out by the community and the two companies, such as Cloudera Dataflow packaging for ARM platforms, deeper continuous integration and continuous development capabilities to streamline data operations into your DevOps practices, and even more. However, with everything still being in motion, it's still too early to tell, though Cloudera has committed to ensuring that the Cloudera data platform is 100% open source. And from what we can tell, that's extremely exciting. Now, say that you're currently using Cloudera or Hortonworks software. It's deployed. What does this all mean for you? As a customer or member of the community, you're benefiting from Cloudera's heightened commitment to open source. They're financially and operationally in a great position and are driving more development and innovation in the ecosystem, which means that their customers' demands and requirements are met faster, and those capabilities are driven even more cohesively. Your current deployments will be supported till at least January 2022, which is in 3 years, rough, give or take, with potential additional support options being explored. Now, if you're wanting to take advantage of this new Cloudera data platform, you have 200 bare metal servers and just want to update to the latest version. There will be a seamless upgrade path for you whether you're on a Cloudera or a Hortonworks platform. Now, between the two companies, they had every major public cloud provider as a large partner. And now under one roof, you can expect best-of-breed hybrid and multi-cloud deployment options. Now for everyone's favorite part of a live presentation, a tech demo. I'd like to show you Cloudera's data science workbench quickly and how you too can jump into some experiments. So here is a sample script, our script that we've already run, produced the results with. How did we get here? As a user, you can collaborate between different contexts and different workspaces with different members of your team. Here I have a few different projects. They can be shared and starred and favorited. We can quickly create a new project. Now this can be from a blank source. You can set up a template, local repositories, or Git, which is what we're going to use today. This is the example training for Cloudera's Data Science Workbench, the repository online. All we have to do is simply paste this in, give it a name, and create the project. What it'll do is it'll clone down that project and deploy it into the base of its file system. Now, here what we can do is quickly jump into the workbench to actually get started with some of these experiments. Now, these are just some basic examples. We have other more complex and in-depth examples that employ random tree forests and other models that are a little bit more complex. But otherwise, this will give you a sample into what you can do. We have other sessions running as well that we can switch in and out of. If you want to run R or Python, you'll have to launch a new session. And these sessions are all spun up with new containers. So as Cloudera is developing these new technologies on Kubernetes and OpenShift, you'll be able to orchestrate these across different container platforms and interact with the actual containers spun up here as well. And what I'll do is set a little configuration. Here we're actually setting some environmental variables for the container itself. We'll create a new session. And now it's spinning up this container. On the left-hand side, we've got the context for our scripts. We can use different sort of interpreters. We can run just selective lines, or we can run the entire documentation itself. And this is actually not running correctly because it's in Python in an R session. So let's actually switch to the R script and run all. From here, it's interacting with the Hadoop distributed file system, pulling in some flight data, and it's actually crunching this experiment here live. Now we've already got it running in a different context, in a different project. And we can see the results here. Again, this is just an example experiment. What we can do here is employ other models, employ other interpreters as you'd like. Now that we've got this simple experiment set up, we can promote it to a model in the workbench. What a model is an experiment that you've already used. You define a set of inputs, you define the expected output, and then you develop this model. As you generate and verify this model, you can then promote it to a job, which at that point you can streamline into your business's operations. There are different ways to collaborate between teams. There's role-based authentication control, all sorts that you can do very quickly and seamlessly in Cloudera's Data Science Workshop, or Workbench rather. There are too many to show at this point though, but again, if you'd like a little bit more information into the different sort of capabilities that Data Science Workbench can provide you, feel free to contact us. We'll be more than happy to curate your own very demo. So now we're excited. We've seen a couple things that we can do very quickly and easily. What are some of your next steps? You've gotten a sneak peek into Cloudera's Data Science Workbench on HDP. What should you do next, and how can you do it yourself? If you have a current Hortonworks or Cloudera account manager, simply reach out to them. A lot of their teams that we work with are extremely active and engaged. If you're in the public sector, we have a series of partner spotlights featuring the Cloudera teams, one of which is the Civilian Sciences team here with Kevin Pence and Dr. Ian Brooks. If you're more technical and want to get started quickly and just get your hands on things, feel free to explore our GitHub repository. There are sources for our workshops, some of our training, as well as some new Ansible playbooks to quickly and easily deploy Cloudera Director, Cloudera Manager, and the Data Science Workbench that you saw today. Before we close, we'd like to open up to any audience members, questions, comments, concerns, qualms, queries, or conundrums, even threats. We'll field it all. Feel free to put your response into the chat window, and we'll answer it accordingly. If we cannot find the answer immediately, we'll make sure to follow up with you as soon after. And as the questions come in, I'd like to take a moment to thank everyone for joining us today and spending time with us. If you're interested in the fast quotes, services, or your very own workshop, please feel free to reach out to us via our main points of contact or to Jamie Borup and I directly. We'll be sending a recording and some additional follow-up information after webinar. If you do not receive this, please let us know. We'll make sure to get you the information that you need. Otherwise, thank you again, and have a ferocious day. To answer some of the questions, this is being recorded. It will be available. We'll email this out. If you did not sign up for the webinar directly, then provide us your email address, and we'll make sure to give you the resources as well, which will recap the recording, the GitHub repository, and other bits of collateral. And in the demo was Hadoop running in a container on your local machine. The Hadoop container was connecting, or the container rather, the R or Python context was connected to a HDP cluster. So Hadoop and Spark was actually being processed on a different worker. You can run it in a single node, but otherwise for our purposes, we actually deployed it on HDP and had all the processing on those workers available. We have a question from George. What if I have a scalable R application that is MPI aware? Is it able to use multiple nodes with MPI communication between the nodes? That depends a lot on your architecture and your application. The simple answer would be yes, but the complex answer is also yes. Since this new platform is running with containers that are spawned, you can actually deploy different sort of interfaces into the container. You can deploy different interfaces onto the workers and onto the gateways as well. So it depends on your architecture. If you'd like, let us know, contact us. We'll be more than happy to work with our counterpart teams at Cloudera to help provide you a solution with this message passing interface.